This is section 6.10. I thought I'd do some at the very beginning. There were some videos for scattered problems throughout, but maybe at the beginning there might need to be a little bit of explanation. Okay, so let's see. Let's just look at number 1. In these problems, you're going to need your calculator, because what they're wanting you to do is show that these two sides are equal. And all you're going to do is use your calculator. You know you can use your calculator for this because since they didn't put the base here, this is log base 10, and that's what's actually on your calculator. So what you can do, if you think about it, log 3 times 7 is the same thing as log 21. So you put it in your calculator, you write down your value. And then over here on this side, you're going to put log 3 plus log 7 in your calculator. You're going to write it down, and you're going to notice that they're equal. This is the same thing as what was going on in problem 46 in section 6.9, is that they were just trying to get you to see how these log rules work and that they really do work. Okay, so going on down to number 7, 9, 11, blah, 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 those. We tried to do a video in class, put a lot of them on the video. The video didn't save, so this is another attempt to get some of those there. I'm not going to do all of them. I think a few of them may have ended up on another video, but I'm just going to choose random ones here. For instance, log 8. They're wanting you to rewrite it in terms of 3 logs that they've given you. They don't want you to use your calculator. And they tell you log 2 is about 0.301, log 3 is about 0.477, and log, again, all these are log base 10 of 5, is 0.699, and they just want you to use this to work the problem. So using the properties of logs, I could rewrite log 8 as log 2 cubed. Okay? Now, if you remember the log properties, that 3 can just drop out front. This is like the power property, and I can rewrite that as 3 log 2. Well, that's 3 times whatever log 2 is. If you look over here, log 2 is 0.301. So if I multiply that out, 0.301 times 3 is going to be basically 0.903. Okay, let's look at another one. Look at number 11. Log 2/3. Now the log properties say I can rewrite that as log 2 minus log 3 because that's the quotient property that we talked about today. All right, I can say, well, what is log 2? It's 0.301. What is log 3? It's 0.477. So that's going to be a negative, and you could put this in your calculator, but if you do, you'll end up with 0.176. So again, I can just use these values that they've given me in the log rules and actually do this, and that's why they're actually having you run through this. Again, just because we did these in class, and I'm just trying to make a quick video to go over them. Log 10, how can I rewrite that? Well, I could write 10 as log 2 times 5. And the log rule says that's the same thing as log 2 plus log 5. If you look on page 278 at what log 2 is equal to in those instructions, it says it's 0.301, and then log 5 is 0.6999. And when you add them up together, that actually is equal to 1. And that makes sense because if you think log base 10 of 10 is equal to something. Remember, a log is an exponent, and if we rewrote this, it would be 10 to the somethingth power is equal to this 10 in the middle. That was that log A, B, C, and we converted over to I, C, B if you're not following that. Well, 10 to the first power is 10. It makes sense that our answer would be 1 there. If you said log 3 to the 6th power, the power property says I can move that 6 out front and just make that 6 times log 3, and they told us log 3 was 0.477, so if I multiply that out, that's 2, carry a 4, 6 times 7 is 42, and 4 makes 46, carry a 4, so it's 2.86, and that was a 2. Okay, so I can just, at that point use my calculator to help me. I'll kind of pick a couple more that looked weird. Number 25 looked weird. Log 300, 0.0. They're just putting the 0.0 on there to mess with you, okay? It's the same thing as log 300. Now, log 300, that's log 3 times 100, okay? There's one thing I could think to do here. Well, that's the same thing as log 3 plus log 100. Now, log 3 is see, they told us it was 0.477. And let's think about this log 100. Let me come over here. This is log base 10 of 100 is equal to something. This is, if we write it as the alphabetical logbook, and then we switch it over to I, C, and B to kind of think about it, the A is 10, the C is the question mark here, and the B is the 100. 10 to what power is 100? Oh, the missing thing is 2. So this whole expression is actually just equal to 2. So this would be 2.477. And just because, let's see, I think 29 was actually on something else. Let's look at 27. Log 3,000. Well, that would be the same thing as log 3 times 1,000. So we could rewrite it that way, and that would be the same thing as log 3 plus log 1,000. Now log 3 was 0.477 again. Log 1,000, remember this is log base 10, and if you get confused, maybe write it in. So 10, remember if I come off to the side and say I'm trying to figure out what that's equal to, log 10 of 1,000 is equal to a question mark. Let's label it with our labeling that we talked about before if you don't see what the answer is very quickly. This is an alphabetical logbook on the pirate ship, okay? And the pirate goes, I, C, B, so it's A to the C power is equal to B. So my A is 10. My C is the missing exponent that I'm trying to find. I'm trying to circle it. iPad's not cooperating here. And my B is 1,000. 10 to what power is the 1,000? Oh, it's 3, isn't it? So that whole thing is equal to, remember a log is an exponent. My missing exponent there is 3. That whole thing is equal to 3 there. So if I add 0.477 plus 3, it's 3.477. So this is the kind of stuff they were having you do there. I think 29 ended up on a video. I'll put it. So just in case 29 didn't end up on another video, I actually think it did. But here's 29, 3 times 10 to the 12th. Well, remember, they're just messing with you there by putting that little X in there. This is the same thing as 3 times 10 to the 12th. And again, if you're looking at the log rules, that's log of U times V. And I can rewrite it as log of U plus log of V. Okay? So that's log of 3 plus log of 10 to the 12th. Well, the log of 3 they gave us, it was 0.477. We're still using those same instructions for this problem. And then log 10 to the 12th, if you remember, the log is the exponent, isn't it? So if I were to say, let's say I don't recognize that the answer there's going to be 12. Let me come off to the side. Log of 10 to the 12th is equal to something. Well, one thing I can do to help me is fill in if it's just log. Remember, it's Lazy Math Guy's way of writing log base 10 since it's the log we work with a lot. So if I were to label this log A, B equals C, it's the alphabetical pirate logbook. And then we change it over to I, C, a B that the pirate says. My A is 10. My C is my missing exponent. It's a question mark. A log is an exponent, and I can see it showing up here as the exponent when I rewrite it. And my B is 10 to the 12th. Well, if 10 to some power is equal to 10 to the 12th, doesn't the missing exponent have to be 12? So remember, the log is the exponent. So this log 10 to the 12th is actually just 12. This is 12.477. And there's my answer for 29.